Hello everyone, welcome to our statistics channel, Quality Statistics. In the last video, we discussed measures of dispersion and one instrument, and today's video we will discuss standard deviation. This is a part of absolute measures of dispersion. Standard deviation of a set of observations is the square root of the arithmetic mean of squares of deviations of the observations from their arithmetic mean. In short, standard deviation may be defined as root mean square deviation from mean. It is usually denoted by the Greek small letter sigma or sometimes by small s. If x1, x2, x3 xn are the given values of the variable x is the variable, name of the variable is x, and if x bar is their am, then deviations of the observations from the mean are x1 minus x bar. X1 is a value, x bar is mean, therefore the difference between first value and mean, this is called x1 minus x bar. Similar for x2 minus x bar, x3 minus x bar, and so on, xn minus x bar. And the squares of the observations from mean are x1 minus x bar square, x2 minus x bar square, x3 minus x bar square, xn minus x bar square. These are all the square measurement. Now mean of the squares of the deviations from mean, these are the elements 1, 2, 3, 4 n by n, that is we get mean 1 by n summation xi minus x bar square. Now root mean square deviation from mean is the standard deviation, that is sigma x equals to or sx equals to root over 1 by n summation xi minus x bar square. The square of standard deviation sigma x square or s square is known as variance. Thus variance equals to sd square or sd equal to root over variance. Variance is always positive and its positive square root is the standard deviation. Our main task is to find out the sd value from frequency distribution. In different cases we will find sd in different forms. Determination of sd sigma. Case 1, for simple series, if you get only x values, that is x1, x2, x3 xn values, then we use the formula sigma equals to root over summation x square by n minus summation x by n whole square. And we give an example in favor of this formula. Find the standard deviation of the observations 1, 2, 3, 4, 5. These are x values. Given observations, that is we form a table keeping x and x square column, that is 1, 2, 3, 4, 5, 1 square, 2 square, 3 square, 4 square, 5 square. Summation x equals to 15, summation x square equal to 55. And sd equals to summation x square by n minus summation x by n whole square root over, that is root 2, and root 2 is the standard deviation. Now case 2, for discrete series, and this is frequency series. If we get x values with their corresponding frequencies, then we use the formula sigma equals to summation f into x square by summation f minus summation fx by summation f whole square whole root over. This is sd formula. Now we give an example in support of the formula. Find the sd of the following frequency distribution. X values are 1, 2, 3, 4, 5. F value frequency are 2, 3, 4, 5, 6. And we make the column x, x square, f, fx, fx square, which are required for formula. And these are x column, this is x square column, this is f column, this is fx column, fx square column. And we find here summation f equal to 20, summation fx equal to 70, summation fx square 280, and putting in the formula summation fx square by summation f minus summation fx by summation f whole square under root, and thus we get 7 by 4, that is root 7 by 2 is the SD value. Now we focus on the third case, that is for grouped frequency distribution, group distribution. If we get the class interval and frequencies, then we use the following methods. Sigma equals to root over summation fd square by summation f minus summation fd by summation f whole square into I, where d equals to x minus a by I. Here d is the new element. D measures the deviations of the x values from assumed mean. A is the assumed mean, I is the class width. And now the example is find the SD of the following frequency distribution. Here class interval is given as 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50 and 51 to 60. And respective frequencies are 2, 5, 12, 11, 40, 30. This is the table where class interval and frequencies are given 1 to 10, 11 to 20 and so on, 51 to 60. We find first mid value. 1 to 10 mid value is 5.5. 1 plus 10 by 2, that is 11 by 2 equal to 5.5. 11 plus 20 by 2, that is 15.5. 21 to 30, that is 21 plus 30 by 2, that is 25.5. In this way we find D. D is x minus a by I. All these values are x, and A is, I assume here A is 35.5, that is 5.5 minus 35.5. This is x minus a, that is minus 30. I is the class width, that is 10, that is minus 30 by 10 equal to minus 3. For second observation, 15.5 minus 35.5, that is minus 20, divided by 10, that is minus 2. In this way minus 3, minus 2, minus 1, 0, 1, 2. And fd is this minus 6, fd, f into d, that is 2 into minus 3 minus 6, 5 into minus 2 minus 10, and in this way we calculate this. Fd square, that is fd into d, minus 6 into minus 3, that is only 18, minus 10 into minus 2, that is only 20, and in this way we get this. The summation f is 100, summation fd is 72, summation fd square is 210. And now we use the formula root over summation fd square by summation f minus summation fd by summation f whole square into I, and putting these answers, putting this derived result, we get root 159. SD value is root 159. This is all about today. Please keep watching our channel for new videos and new updates. Thank you all for watching this video.